This week on the Embedded Insiders, Brandon and Rich discuss an age-old controversy. What's more secure, proprietary or open source software? That discussion leads into an interview with Kate Stewart, Senior Director of Strategic Programs at the Linux Foundation, who joins the podcast to explain how the Zephyr Project responded to 25 vulnerabilities recently uncovered in its open source codebase by the NCC Group, an independent security analysis firm. After reassuring the insiders by detailing the steps taken to remedy those bugs and explaining the security practices in place at the Zephyr Project, Stewart continues to introduce the Embedded Linux and Safety Applications, or ELISA project, which seeks to better align Linux software and tools with the requirements of safety-critical industries. Where does ELISA fit in with other projects like RTLinux? And how can the software test community help accelerate the expansion of Linux into platforms ranging from road vehicles to rockets?
Welcome to the Embedded Insiders. I'm Brandon Lewis, Editor-in-Chief of Embedded Computing Design, and I'm here with Rich Nass, who's the Brand Director, VP, Overlord of Embedded Computing Design. How are you doing, Rich?
I am doing good, except that your intro makes me think of Darth Vader, and I don't know if that's a good thing.
Okay, I have a question for you. What does Darth Vader say? What's the most famous line in all of Star Wars?
Well, I know. Well, it's not a Darth Vader line, but the Darth Vader line that I always hear is, "Luke, I am your father."
Have you ever heard of the Mandela effect?
I have not.
So the Mandela effect is this theory that, there are, string theory, universes collide and things change, and things that we all remember are not now the way that they once were. So in the Mandela effect, the Darth Vader Star Wars thing is an example of that. He doesn't say, "Luke, I am your father." He says, "No, I am your father." Do you believe that?
Well, I have all the DVDs here, so I'm going to go back and look when we're done. But where are you going with this?
I don't know. I heard about the Mandela effect and I was reading about it, and anyway.
All right. Well, I have actually there's another line from Star Wars that I live by, and I think that you do as well. And one of my kids actually made it for me for Father's Day the other day. It is the Yoda quote.
There is no try.
Do or do not. There is no try.
Yep. I actually have that on my desk in the office, which I haven't been to for a while, so I'll have to.
So what does this have to do with open source?
I don't know. Yeah, this is a mess. Well, there's so many Star Wars fans out there. I hope they appreciate
Absolutely.
That. Yeah, so we're talking about open source, and we've actually been talking about that fairly frequently lately. And there's a debate that's been going on for years about whether or not open source is more or less secure than your traditional proprietary offering. And we're actually going to get into that a little bit later with Kate Stewart of the Linux Foundation, based on a report that the NCC Group published. But what's your take? Open source or closed source? What's more secure?
There is no question that, I don't know if closed source is even a word, but a commercial piece of software is way more secure than open source.
Well, why is that? Because the argument is, and it's hard to refute, that if you have open source code that's out there in the wild, I'll just take Linux because it's the most popular example. There are millions, potentially millions of eyeballs sitting on that code, looking at how it's reacting in certain contexts, what happens when you access this sort of resource, or you call this function from memory. How can you compete with that if you're just one company?
Because there's a percentage of those people whose eyeballs you have looking at it are wearing a black cowboy hat.
What does that mean?
That means they're bad guys, that they're looking to do malicious things.
I'm from Arizona. Black cowboy hats don't mean you're a bad guy, but
white hat, black hat.
I know. Well, I don't know if I completely agree with that, because just because they're a bad guy, that doesn't mean that they're able to change the code in a way that everybody else isn't going to recognize. There are also people wearing white cowboy hats that are looking at it. And I would like to assume that most people are wearing white cowboy hats black ones.
But don't you assume that most people who are making adjustments to this code are making these adjustments to make the code run more efficiently and don't really have their eye on the security ball, whereas a commercial vendor is staking his company on the fact that the code is secure?
That's one thing that I will concede, is that if you are a commercial vendor, you're developing your code within certain contexts. Like an operating system vendor, for example, like Wind River or a Mentor, develops their operating system and then ports it to a specific target. Now, the problem that you run into if you're in Linux is, maybe there's a certain distribution out there and you're trying to optimize it for a particular use case, and so then that code gets upstreamed. Everybody's out there using it at will, but it may not have been considered in the context of which you are looking to use it. Now, in this case, Linux may be a bad example, because if you're a data center, for instance, it's a pretty Intel x86 dominated environment. But in other cases, let's say, like we're going to talk about Zephyr in a little bit, Zephyr is an IoT RTOS, and the problem with having an IoT RTOS is that you have to make sure that it's ported to a bunch of different platforms. And in the MCU world, having all of these different architectures can mean, okay, well, I looked at this code base on an ST target. It works great in this context, but what about NXP, Microchip, every other architecture out there?
Yeah, but I don't know if Zephyr is really a good example, because it isn't what we call classic open source, in that just anybody can go in and willy-nilly make changes to it. It's open source in the fact that it's free, but it's not open that you could just go in and make changes without somebody approving those changes.
They're maintainers of most popular open source software. It's not like, you go in, you change the code, and then the code is that way for everybody for all time. You have to pass it through a maintainer, otherwise none of this stuff would work.
Mm-hmm.
But it may just be that who is the maintainer, right? If the maintainer is somebody who is used to this sort of environment, like an ARM-based environment, for example, they may be running security checks or putting the code through its paces, thinking about it this way versus that way.
That's fair.
The Insiders are now joined by Kate Stewart, Senior Director of Strategic Programs at the Linux Foundation, who explains how the Zephyr project responded to vulnerabilities found in its codebase. More information on embeddedcomputing.com in the article Another IoT Security Uh-Oh, 26 Flaws in Open Source Zephyr and MCU Boot Stacks.
Recently, NCC Group did an independent security analysis of the Zephyr operating system, and they found some vulnerabilities. There were 25 or so. I wanted to know what has Zephyr done at this point to address some of those findings from NCC?
So at this point, before the report came out, we had addressed pretty much all of the critical high and most of the medium severity bugs. And the fixes for those all went into the 2.3 release, which is our development tip when the results came in. And we've also got backports going back to our LTS and to our last release, which was the 2.2. And then it was a 1.14.2 release that came out. So those all have the security fixes in them. And we're taking security pretty seriously at Zephyr. There's a security incident response team that has done a lot of the work of doing the analysis and then making sure that the backports as well as the fixes are in place.
Critical bugs. Is that just somebody's opinion that it's a critical bug, or is there an actual benchmark that says this is critical?
How the NCC Group classified them, and so I'm just relaying it on from that perspective. But we went through how they've classified the bugs, and then we did our own analysis, and this is what we made sure we fixed. And we opened up we have our own database, and we worked it through onto our release criteria actually for the release to make sure that everything was addressed.
And actually on that point, the Zephyr project has a little bit of a correlation with CVE, CWE, isn't that correct?
Yeah, Zephyr Project is one of the few open source projects. It's actually its own CVE numbering authority, or CNA. And we've had this status now for a couple of years. Up till this point recently, we've just been getting ones and twos type of vulnerabilities being reported to us by researchers and things that we found. And so we're really very appreciative of the efforts that the NCC Group did to go through and really study the code base and find issues for us. In Zephyr, we already do a certain amount of static analysis with Coverity, and we're sort of always looking for ways to help to improve the code base and harden it. And the fact that the NCC Group found these vulnerabilities and they're now fixed is really exciting for us.
So just to say it in plain English, anybody who's now moving on to Zephyr 2.3 is going to be fine. All of those mid to high level vulnerabilities have been patched, fixed, and they're good to go, right?
Indeed, they are, yes.
In theory.
There's always more vulnerabilities out there. There's always code.
Right, exactly.
But okay. We are very transparent about our code base, and we welcome people working with us to fix it, to make it better.
Sorry, I played the cynic role here.
It's okay. I'm sort of cynical. Like I say, bugs happen. And I think that the best indicator for higher quality is the transparency of the source code.
We should make a bumper sticker, bugs happen.
Oh, yeah.
As far as the development practices, though, there is a formalized committee and working group you mentioned that whenever there are new versions of Zephyr, it passes through that committee. But what about the community?
Well, so we actually have a security community that meets every 2 weeks to look at anything that people have flagged as potentially a security issue. So we have an active working committee chaired by Flavio Ciolen from Intel, and then our security architect is David Brown from Lenaro. And they have the expertise in this area, as well as other of our members are participating actively in making sure that we make our code as robust as possible and are adhering to the security best practices. All of our security practices have been documented, either on our documentation on our website, or we've also have the CII best practice badge that is a project that's been sort of started about 5 years ago. And Zephyr is actually one of the 5 gold badged projects, and we've been there now for about a year and a bit. Our projects that care about security as well as quality, we've gone in and publicly documented and passed the criteria.
Kate, there's also something going on within the Linux Foundation, unrelated to Zephyr now, but it's called the ELISA project. Can you explain what that is a little bit to us?
Yeah, so the ELISA project is focusing on figuring out what we need to do to close the gaps between what's happening in the safety standards world and with Linux. And so it's more focused about safety rather than security. Linux right now has a whole infrastructure around security. We're seeing Linux being used in a lot of safety critical applications, but we're not seeing the same sort of community available that's there for security actually happening for safety. So ELISA is there to help start to form that community and to start to help figure out how we can make the Linux kernel more robust and more dependable in these types of circumstances.
I think that's pretty awesome because so many people lump those two things together and they assume if your system is safe, it's secure, and vice versa. And it's nice to see you guys are actually breaking that apart.
Right. And, we're talking about ELISA here too, but Zephyr also has a safety community that's also looking at safety as a separate topic than security. And they're focusing on what's necessary to put the evidence in place that you can go after safety certification there too. So both projects are looking at safety, Zephyr and ELISA. And like I say, Linux has a really good set of people working on security already and has security summits and so forth. And Zephyr is trying to grow in that direction now.
With the ELISA project, what work is being done there? I know in the past there's been real-time extensions for Linux, et cetera. Is ELISA building off of that work, working in parallel with, collaborating?
Well, ELISA is focusing on the upstream, and so in that sense that the real-time Linux is working on focusing on getting all the preempt RT stuff upstream because a lot of safety applications need real-time. Mm-hmm. So there's a definite follow-on from having the real-time preempt RT and real-time upstream. The ELISA project is looking and trying to understand what the safety certifications are asking for in terms of evidence, and then trying to figure out how what we're doing in the Linux kernel today is actually matching up to that. So we've got, I guess, 3 different ways of looking at this. We've got the way of how does what's happening in this kernel match up with what the standards are asking for, and the safety culture, and what are the gaps. So there's a working group specifically focused on what are the gaps, the hardening configuration for the security, what might be the equivalent for safety, what are the good defaults to use. So there's people looking at that. There's another group of people that are looking at, okay, there's a lot of functionality like memory management, isolation, how the scheduler works, things like that, those types of concepts, and looking at it from the software architectural level and trying to figure out, okay, what are the important pieces, what are the interfaces, how do we make sure that we can do the right argumentation for what's in the kernel today. The third group is, and actually it's the 4th, 5th, and 6th too potentially, is how do we take and look at a system and understand where Linux is being used in the system and what is necessary and sufficient for the argumentation to convince yourselves that you've made it as safe as you can if you've got Linux in it. And all the safety standards that I'm aware of pretty much don't take a project on its own. They take a project in the concept of a system.
Right.
And so what are some reasonable ways of breaking this down to the extent that we can understand what the interfaces on the system are? And then how can we do the prove it to ourselves that we're going to be safe? Linux is sitting in some of these scooters, right? Mm-hmm. In the braking systems on these scooters. You don't want to go head over heel on them. There was actually, I think, some vulnerabilities were triggering some things a while back. Linux is sitting in our rockets today. The recent SpaceX launch of the Dragon capsule. The rockets have Linux in it, and I think the capsule has Linux in it, and other open source software for that matter. So Linux is pretty pervasive. So how do we make sure we've done the right due diligence to make sure that we've thought of all the things we need to think about, and that the right levels of testing are in place, the right levels of quality are in place. How do we make Linux dependable? These are sort of the questions that group's tackling it from the 3 different aspects. What's there today? How do we need to look at what's inside Linux? And then how do we need to look at Linux in the context of something else?
All those test guys out there, you mentioned Coverity and using static analysis, they're probably chomping at the bit because this could open up a whole new world for them.
We've got some really good relationships starting to go with various people. Coverity has been very good about making a free version of their tool available to the projects. Linux has Coverity scans going on a regular basis, so does Zephyr. We're also talking with some other vendors right now about making their tools available to the projects so that we can help to make things more robust. We obviously want to get more open source projects. There's a lot of work that's going on in the LLVM ecosystem on fuzzing and these forms of testing. The more testing we're doing on these and the more bugs we're finding, the more we're going to be able to depend on the code.
Stewart will present on both ELISA and Zephyr projects during the Linux Foundation's Open Source Summit North America, a virtual event taking place from June 29th to July 2nd. For more information or to register, visit events.linuxfoundation.org. Thanks for listening to this edition of Embedded Insiders. For daily industry news, videos, and podcasts, visit our website, embeddedcomputing.com.